This is a CIA past paper 1 question from year February March 2018. So here the question states that express the equation 5 plus 2 tan x by 3 plus 2 tan x equals to 1 plus tan x as a quadratic function in tan x, and hence solve the equation for x between 0 and pi. That means x is between 0 and 180 degree. So let's start now. So here we can see 5 plus 2 tan x over 3 plus 2 tan x equals to 1 tan x, and then we first express this in terms of quadratic equation, and then we solve that quadratic equation for tan x, and hence x. So by cross multiplication you can see that this is 5 plus 2 tan x equals to 1 plus tan x, and then when you transpose this towards right, it's going to be multiplied over here. So this is 3 plus 2 tan x, and then you simplify it, so it is 5 plus 2 tan x equals to plus 2 tan x we multiply by tan x, so it is tan x means 3 times of tan x, and then plus 2 times of tan x times tan x is tan square x, and then you can see from both sides these two terms have been cancelled out, 2 tan x, 2 tan x, and you are you can also say this as the principal value, but we don't need this because x should be between 0 to pi inclusive. And now we shall try for another answer. So let's take a reference of a tan graph simply, although you don't need to draw the graph over here, but if you draw the graph it will be a good idea. So let's now take here that one line of reference as it is 0, and then you know that graph of tan shows asymptotic nature about theta equal to pi by 2, and here in this case x equals to pi by 2. So this is y-axis and this is x-axis over here, and then we work up to pi because it has said that to get the solution up to pi, so we work up to only pi, from 0 to pi. And then in that case we can say that at 0 degree of tan, this is the tan graph I am talking of, graph of y equals to tan x. Alright, so here if you talk y equal to tan x, means then at 0 it is 0, and then after that if you increase the value of angle, the tan value will start increasing, and it goes near and near to when x equals to pi by 2 in this case, then it shows the asymptotic nature. That means it doesn't touch this line x equals to 2, and hence it shows asymptotic nature about this sort of line. And pi must be somewhere here now, and you know that at pi the value of tan is 0 again. Right side we don't require it, but left side when you come near to this line x equals to pi by 2, then again it will show asymptotic nature about this towards negative infinity side, and it is towards positive infinity side. Alright, so this section of tan graph we are taking here, but we are interested to find the solution for this. You can see that here from here, like we are only considering this equation, tan x equals to half. That means there are two facts. You can say one of the y is tan x, and another of the y is, we can say y2 equals to half. That means you can say here that tan x equals to half. That means there are two lines in fact, and equal to these two lines are when equal, then they intersect at some point. So that here we have this is the graph of tan x between 0 to pi inclusive. But here again you can see that another line is half, so that the point of intersection between this line y equals to half, you can say here this is y equals to half, and this curve is at some point over here, and from this you can see that the first intersecting point is in fact the principal value, and this value we have found as 0. This is 0.464. Alright, now we work out for other values of other solutions of this sort of equation within 0 to within pi. Even though we have neglected this value of x as x equals to minus 1.107 radian, but it will be useful in finding the another solution for x, because you can see that this up to here this is pi we have, and x is supposed to be in between 0 and pi. So in that case there is possibility that there will be another one solution as well, and then we have to find another point of intersection by taking one equation as y equals to tan x and another as y equals to -2, and these two lines, and if these two functions are equal, that means there is a point of intersection between these two sections, and then probably your line will also be like that, where it is y equals to -2. And in order to do that, although the negative value of x has been neglected over here because of the given domain of this function, And then what you can do, actually we can just consider as a reference that some other point about here, you draw a line about here, and you can say this line as minus 2 by 3, sorry, negative pi by 2, and then let's go up to negative pi over here. So your another line will be like this, okay, where negative 2 pass through, this passes through, and then this point is negative pi, and you, if you extend this graph up till here, then your graph again when reaches the line x equals to negative pi by 2, it shows the asymptotic nature like this. And then you can say that at this point, at x equals to negative pi, this is again 0, but when it is nearing to this line x equals to negative pi by 2, it will show the asymptotic nature about this line. And then this value, you can see that pi is here, it is somewhere here, and then another value pi by 2 is here. And then if you check the calculator, then you can see that pi divided by 2 is something like 1.57. so pi, negative pi by 2 is itself 1.57 nearly equals to, then this point x equals to negative 1.107 must be here inside that negative pi by 2, and that will be given by the point of intersection between tan x, y equal to tan x, and y equal to negative 2, that is y equals to, this line is minus 2, y equals to, this is y equals to minus 2, okay. And so this value is known to be negative 1.107 nearby radian. And now this line intersects the curve again at this point, and you can see that this point has been raised after you add about this point 180 degree. That means your another value of x at this point is going to be x equals to negative 1.107 and plus pi. Okay, so let's take a calculator, and in the calculator we can put negative 1.107 and plus pi, and then that is going to be equals to 2.035 radian. So this point is going to be 2.035 radian. So therefore you can say the solution for this sort of equation is now, one possible value of x is, you can see here, 0.464 radian, and another possible value where we get the solution for this equation is 2.035 radian, and these are the answers. Now in the same question to the part B, you can see that this is a given curve, and let's see what question says about this. So it says that the diagram shows part of the graph of y equals to k sine theta plus alpha, where k and alpha are constants, and alpha is between 0 degrees and 180 degrees. Find the value of alpha and the value of k. In that case, you have to analyze this graph actually. So along the x-axis, you see that along the x-axis theta has been plotted, and along the y-axis y equals to k sine theta plus alpha is plotted, and by this condition you have to find the value of alpha as well as the value of k. So in order to find the value of alpha, you have to check at some point here that when theta equals to 0 degrees, y is going to be 0. And here when theta is 0 degree, y is going to be 2. So we'll use these two facts, and then we'll check whether or not we are up to the solution. So first start with this point. So where theta is 150 degree and y is 0, then write here 0 equals to k times of sine 150 plus theta, and then you'll have after that sine 150. This is not theta, I think alpha, yes, 150 plus alpha. When you transpose k to the left over here, then you will have here 0, and you know that sine inverse 0 is 0, so you can see here one of the value as yes, one of the value of 150 plus alpha equals to 0, it gives you alpha equals to negative 150 degrees. But your question said that alpha should be in between 0 to 180 degree. Then we'll try for some other value of sine angle of this, where sine is 0. So another value of 0 is 150 plus alpha, you can write that is equals to 180 degrees, or you can just transpose this towards right, you can say sine inverse of 0, and that occurs that also 180 degree, and therefore alpha in this case we found as 30 degree. Okay, so one of this constant value we have already found it. Now we shall use this point 2, where you can see and this equation, and so here you can see that y value is 2 equals to k, and then theta value you have already known. Theta value is 0 here, so first of all let's write it is sine, and then theta value is 0, but alpha value that we have got is it is 30 degrees. So in fact it is going to be equals to 2 equals to k sine 30 degrees, and you know that sine 30 degrees value is, this is k times 1 by 2, so sine 30 degrees is 1 by 2, and therefore k equals to 2. When you make cross multiplication from both sides, then it will be 2 times 2, and then that is equals to 4. So therefore in this case your value of alpha is 30 degrees, and the value of k is 4, and this is the answer. Alright, so in this way, before you start to solve the problem, first of all read it properly and try to understand what the question has given and what it is asking you to find. And once you have all these things clear, then analyze the figure or analyze the given data in order to reach to the correct solutions. Okay, so that's all for now.
Hey, before you go further into this class video, please don't forget